Welcome to the Iferia TechCast, where we bring you all things science, engineering, technology, and innovation. I'm your host, Ezekiel Iferia, and today we are joined by Dmitrii Radivonchik, a software engineer and quantitative technologist, building the hidden infrastructure that powers modern financial markets. Working at a firm founded by former leaders from Citadel and GETCO, Dmitrii engineers systems where milliseconds matter and real money is on the line. His work designing production-grade analytics frameworks and real-time data systems shows what it really takes to turn raw data into high-speed trading decisions. In this episode, we'll unpack the intense realities of high-stakes engineering, how building for quant trading differs from traditional data science, and the messy reality of keeping bulletproof infrastructure running. So, Dimitri, it is a pleasure to welcome you to the show today. Thank you very much for taking the time to join us here.
Thank you for having me.
Yeah, it's great to have you. So let's get things started, Dimitri. Your background sits at a fascinating high stakes intersection, software engineering and quantitative technology. So how did your journey begin and what drew you from traditional software into the fast-paced world of finance?
Yeah, so I think it all started when I was in the university. I think it's like third year out of four. I was doing my bachelor's, and at the time, basically, I was already kind of enjoying software engineering. I was working at a local company in St. Petersburg, and which I started in like 11th grade, and I was really enjoying it a lot. It had to do with programming in C, which is quite low level, and in third grade, I some of my friends basically got some offers to internships to like the West, let's say, to London, to Amsterdam. And I started looking at like they told me about those companies, they told me about those fields and like the problems that are being solved there. So I did a lot of my own research and I liked it very much. I thought that definitely something that I would like to try myself in, and I was hoping that I can get it, kind of. So I started preparing for interviews and stuff, and then I got an internship offer. I went to Chicago after the third year of my university for an
Hmm.
internship, and then I came back for my final year when I graduated. And during that final year, I basically did a couple more interviews to get a role at Radix Trading, which is where I'm at now in Amsterdam.
Okay, all right. So, Dimitri, if you are actually to break down in simplistic terms to the layman what you're currently doing, what you're currently building, what you're working on, how would you put it?
I think I'll try my best to keep it
Mm-hmm.
simple, let's say,
Oh,
but at the same time, one thing that is certainly true about finance world is that you have to wear multiple hats. So there's no one project or one major theme that I'm kind of, focusing on. There's always a couple and you always have to go deep into things, let's say. Actually, there's a bunch. So one of the things is real time monitoring of our production trading. Basically, we trade like all across the globe, and it's happening real time. And we need our humans, our traders, to oversee the trading. And to do that, they need tools to actually be able to view data and view the state of our trading as it is getting updated in live in real time. And that has to do with ingesting a lot of data very quickly and presenting it in the ways that they see fit and that they want to see them in. And
mm-hmm.
yeah, that's one of the big projects. Another big project is how we approach maintaining a centralized system of that decides how to generate our production configs. So we have a lot of systems, and those systems, like throughout our time iterating on improving those systems, we figure out some intricate information about what's the best way to set up a system in certain circumstances. And we would like to kind of propagate that knowledge across systems because there's a ton of them. And to do that, we needed like a centralized system that is going to make those decisions. And that's another thing that is really big on my list. Yeah. I mean, I can continue or we can narrow it down somewhere.
Okay, all right. That is a clarifying response, Dimitri. So, you specifically mentioned wanting to clarify what it actually means to build systems that turn data into trading decisions. So, for our audience of young engineers and developers, how does this fundamentally differ from what most people picture when they hear the term data science?
I think the big difference is that a lot of when in classical data science that there's no or there is but like the notion of your production is very much different from that in the finance field. So in the
Right.
finance field you have to build a product, or not product, but like a system that is reliable, and
Mm-hmm.
the system has to withstand load. The system has to always operate correctly because we rely on our systems for trade, for driving our trading decisions. And that is especially true when the markets are busy, the risks are higher. And so the only way for us as a firm to continue existing is to be confident in our systems. And that takes a lot of effort, a lot of thinking and engineering from both the engineering team and the research team and everyone involved. Like it's a major thinking shift, major paradigm shift, let's say, because if your model misbehaves on some data in production, that can be one level of, let's say, accident in a classical data science setup. Like if we're talking about large language models, right? Someone is not getting their
Mm-hmm.
response correctly. That's sad and bad, and certainly like deserves attention. But it's not the same as the firm just ceasing to exist in the next 5 minutes. And so to protect against that, you have to be very confident in your model's behavior. That's one thing. The other thing is that the inference of your models, like the way the models are built, has to be kind of driven by how you run those models and infer those models in production. So you cannot just keep everyone very much away from what is happening in the place where you actually infer those models, where you actually participate in the trading activity. You have to kind of back propagate that information back to whoever is designing the models, because otherwise there will be no way to efficiently implement them in production. And at that point, that model, like if the model predicts the future perfectly, but it predicts half a second away from now, but takes 1 second to do so, that's not useful for us. We have to
Mm.
look into the future, and yeah, to achieve that, you have to back propagate basically information about how your production is set up and what you are able to do in production back to whoever is designing the models so that they can behave correctly in those circumstances.
All right, all right. So let's talk about the infrastructure itself, Dimitri. What does the tech stack look like for a modern quantitative trading firm where milliseconds matter and real capital is on the line?
Yeah, there's so the I think the software stack is in many ways kind of not standardized, but it's quite common. There are exceptions, but most trading firms actually use C++ for all of their production software. And then they use a lot of Python for multiple things, for configuring things in between, for like figuring out how to run the C++ software, for for all of their data science, because you just do data science in Python. There's no way you can do it in C++. Well, maybe there is, but like not a practical way. And so the industry just accepted Python as the way to do your data science. And so that's kind of how the stack looks like. Now, obviously,
Mhm.
normally that's just languages, right? And you would expect something like you would expect like a list of libraries or solutions and so on. But if we're talking about trading infrastructure, you have to take advantage and you have to be able to specialize and control everything that you do in production. Every instruction deserves attention that you run on the actual CPU in production. And for that reason, like I'm confident that all of the software that is running in those systems that actually makes trading decisions is custom written, is just basically whatever engineers have built in C++. And one of the benefits that gives is the perfect modifiability, let's say, adjustability, like customization, right? So if we decide that we want to slightly tweak how we execute those instructions in production, we are totally in position to do that, as opposed to using any third-party software where we have no control over those tiny bit details. Yeah. Now, that covers the kind of the production setup. Although I know that there are other firms that are kind of using other languages, but that's quite uncommon. So normally it's just C++ and Python. Yeah.
All right, all right. So, I'm still curious about the realities of building for extreme reliability. So, can you walk us through a challenge, like ensuring a system doesn't make a catastrophic error at light speed? So, what does that engineering and testing process look like from the inside?
Yeah, of course. Well, there are some boundaries I have to keep myself in because I've signed
Yeah,
some
yeah,
documents,
sure.
obviously. So I'll try to be vague a bit, and that is
Okay.
intentional. Because
Yeah.
otherwise, yeah, that can't work. Yeah. But to the extent that I can tell you is that the way those things are approached, so obviously there are, let's say, normals. The way you build this software is that you, on one hand, you want it to always do the right thing. You want as few bugs as possible, which is kind of,
Mhm.
universal across all software branches. I'm sorry, of software engineering. So you never want bugs. But in here, you on one hand take extra caution to prevent any bugs from existing there, but that's
Mhm.
never enough. Like it's not statistically feasible to actually rely on never writing buggy software because that's just not how software engineering works. And that's why you have to kind of protect against the faulty cases, and the way you protect against them is by implementing multiple layers of protections. So normally you have, obviously, your production is like a whole array of binaries, whole array of processes, right? And so you try to protect yourself on as many levels as you can. Because again, the cost of the mistake can literally be your company is gone. And so you implement basic checks in the code itself. That's the first level. That's kind of, universal, like everyone does this. But that's kind of fundamentally not enough, because when you build against when you're trying to protect against the failure, one of the failure modes is that some software developer has made a mistake, has introduced a bug, and now the software is not behaving correctly. If you kind of make it such that your check for validity is coming from that same software that you're trying to prove is behaving correctly, that's fundamentally wrong, kind of, right? Because if your program misbehaves, then it might as well misbehave in terms of how it enforces its own behavior, not enough. So for that reason, like even though we have already implemented multiple levels of checks in the code itself, and the specifics here depend on the code base, right? So if you have, I don't know, 10 classes, you try to protect in as many of them as you can, but that's not enough. And so that's why you kind of implement external validation. So external validation that is basically tracking what actions your processes are taking, and making sure that those actions kind of make sense. And if they don't make sense, then you kind of fail hard. You definitely alert people so that it can get proper attention, but you also
Mhm.
have to fail hard and kind of immediately. Because again, the speeds that we're operating on, like it's not feasible to expect a human to react and be able to understand what's happening and what's the right action to take before the bug can take out the firm. I mean, that hasn't happened yet, which is why I'm still working there because the firm exists. But yeah, that's something that everyone in that entire industry is trying to protect against. Yeah, some failure modes that just force you to acquire risk, like amounts of risk that you're just uncomfortable with, and that can actually drive you out of the business. Yeah, so that's how you kind of take that. Obviously, on top, but that is on a low level. On a higher level, there's our standardized stacks of tracking and alerting that we all, like many of the trading firms use, and that is also obviously in place, and that allows for more, not subtle, but like more at scale, more holistic view of what your trading systems are doing. Yeah, that doesn't give you the time constraints, and doesn't meet the performance criteria, the latency criteria that you're looking for in the enforcement of those things otherwise. Though all of those layers have to work together to kind of give you a whole picture. Yeah, that's how we approach it.
All right, Dimitri, that was a really insightful
Mm,
response
thank
into
you.
how your approach goes. So you've talked about the shift from AI first to AI audited systems. So, why are trust and control so critical when building these models? And how do you actually audit a system making decisions that fast?
Well, there's multiple. So I'll answer this in parts. So you ask why,
All
and then
right.
you
Yeah.
ask
Yeah.
how. I'm going to
Yes.
address why first. And why is so there are a couple of reasons. One of them is that we as a firm want to progress, want to be confident in what we are doing and have observability into the decisions being made. And since that is going to be useful sources of information for future development, and that's not necessarily software development, it's just development in general. And that's one reason why you want to understand your behavior in production as closely and as in detail as you can. The other thing is that in many cases, like many of the exchanges that comprise modern financial world, let's say, they actually require you to be able to provide some audits and some trails of why you made certain decisions, because they're trying to protect against fraud, they're trying to protect against market manipulation. And a lot of the legitimate trading in many cases looks like market manipulation. So that's a
Mm,
an interesting task that kind of is specific to the field, is that the people doing the shady stuff are not that far off from people who are doing a legitimate thing, but have no bad intents and like have all the reasons to do what they're doing. Yeah, so and that's why you have to keep very detailed tracks of what we are doing and why, so that if you were to get inquiry, they can request that information for some years back, and you have to keep it and have to be able to provide it to them. Otherwise, their fines are going to be enormous, because those fines are like on par with what the financial damage is that you could have done or have done to the markets and participants. And so, yeah, and that amounts to a lot. And so
okay.
that's the how part, I guess. It's the why part. Now the how part is, well, you have to design for it, because one thing is you have to, before anything goes to trade and production, like you obviously have some simulations, you have a lot of checks that you have to pass, that your model is behaving the way you expect it to behave, and that the decisions that it is making are in line with what your learning process was like, right? So it was because the environment in which the models are created and trained is not the same where they are inferred and like where we actually trade. So you have to reconcile the two. You have to make sure that the behavior in one of them is the same as the other one. And there's a ton of thought. Again, can't go into too many details, but generally there's a lot of thought and designing and engineering and resources behind making sure that our behavior in the trading process is the same as in production.
Yeah, yeah, Dimitri, that was a really a fantastic response. So, the discipline required to build this high performance system is I mean, I think it's quite intense. So, what's one engineering principle from the quant world that you think software engineers in completely different industries should adopt?
Let me think about this one because, as you have noticed earlier, or as you've noted earlier, a software engineering in the quant world is quite different to software engineering in anywhere else, let's say.
Mm-hmm.
The industry is quite special, and so the way your work is assessed and the things you're kind of expected to do and the things that are optimal to do if you want to do a good job are quite different from those of um like the proper software engineering firms, because many of the firms, if not all, but many for sure, one of the parts of the mentality that they have is that they keep reminding people that the firms are trading first. They're not software engineering firms, they are trading firms that employ a lot of software engineering. So one thing that is quite different is that you always keep the trading in mind. You use software as a tool to do trading, but the way you make your decisions is not by how do I create a better product, or how do I create a better piece of software that is better to work with, and so on and so forth. Your decision making is always coming from trading decisions, and how software influences that. And that's a major shift between financial firms and trading. Oh, sorry, and the software engineering firms. Yeah, and that's why I think a lot of the guidelines that I would derive for I think the list of guidelines that I myself would give to a classical software engineer is very much different from those I would give to like a quantitative software engineer. I mean, the common things are all the I think the advice that I would give to quantitative software engineers
Mm-hmm.
is try to be more like classical software engineers. So a lot of the basic principles of good software engineering, like even like they apply to a full extent to financial field, and some of the benefits that they provide, they are less apparent, and you would think of them like it's not the first thing that would come to your mind, but if you just stick to them, that's just automatically gonna improve everyone's life and performance. And I guess that can be reversed too, because in many cases, I think with classical software engineers, and I had to kind of eradicate that from myself as well when I was kind of transitioning from normal software engineering into finance, is when you're approaching software engineering as a task of creating software, just software in vacuum, and when the way you assign value to things is by how well of a software product you're going to have at the end, that kind of puts you in a certain mindset that is optimized for producing software, but is not necessarily optimized for business performance. And that is something that I would advise reconsidering based on my experience in financial field, because when you're a software engineer and you are developing software that actually affects like lives and lives of millions of people, then it's a certainly a good thing to give more consideration to how the software is going to apply to their lives, as opposed to just focusing on creating good quote unquote software. So I think that's a guideline that is common to financial world that I think everyone could benefit from.
Okay, so for the engineering student or maybe an early career professional listening right now who wants to break into quantitative tech, so what does that transition look like? What skills do they need to develop that they won't necessarily learn in the standard university curriculum?
So I think some of the skills, I think the most important skill that I've acquired or had to develop as a part of that process was being self-sustainable in a way, like taking projects from the very beginning of like, gathering the requirements and understanding, scoping out the project and understanding what its place is going to look like in the overall picture, and then taking all the way from that stage, taking the project to the very end stage of like maintaining its life cycle, so on. Being able to do every step, every stage of that process is very much a skill to be had in that field. It's very much valued, and it is something that you yourself will appreciate having if you were to get into that field. That's also something that people, I mean, interviewers are going to be looking for in their interviews, because if you're like, you have to be able to play, you have to be a great team player, that's for sure. But a lot of things, in a lot of cases, you have to kind of define your own projects, and that will bring value, and then take them to completion, and be able to do that on your own is very valuable. So I think that's the most important thing. And then I think kind of focusing on basics and like fundamentals of software engineering, fundamentals of computer science is very, very helpful. So just being better at coding, being better at interacting with software, and having your pet projects, and like being able to come up with them, deliver them, all of that is how I think you should approach transitioning into that field.
Okay, all right. So, Dimitri, when you look at the future of infrastructure and trading, what emerging technology or shift in data engineering are you most excited about right now?
I think, I mean, the way the LLMs were progressing lately is actually very exciting, because that, I think, shifts the entire industry of software engineering and the role of software engineer to a whole new level. That, I think, is very exciting. And even though, obviously, I mean, not obviously, but the purpose of LLMs is not to serve the financial industry, and that's not necessarily something that you're going to run in production or something. Like it's not a model that you would. It's not optimized for any of the financial decisions or anything, but it affects the finance industry a lot, because it allows for quicker software engineering. It allows for better visibility into your systems, and in terms of like analyzing them, and in terms of quickly iterating on ideas, on projects, and so on. I think that that is definitely the field that is, or the theme that's going to have the most effect on financial industry. So it's not about, to me at least, as a software engineer, right? It's not about some new approaches to data science that I'm most excited about. I think it's the development of those AI models, of those agentic models, all of that. I
All
hope that
right.
answers.
Yes, yes, it does. It sure does answer the question. In the context of your work building the hidden systems that power modern markets, what does innovation truly mean to you?
I think this is a deep question, and the answer is going to consist of multiple parts. So one of the parts is that what something that is intrinsic to the finance industry is that innovation is always a competition in that field. What that means is the market is full of players, and those players are competing each other, and everyone wants a bigger piece of the pie. And basically, whoever can invent at a higher velocity, at a better rate, let's say, whoever can do that, they win. And that those effects can be felt very, very sharply. Let's say it's like clear as day. And so, as soon as you stop innovating, you're actually gonna start lagging behind very quickly. So to keep at the same pace, to keep in the middle of the pack, let's say, in that industry, you have to innovate at a crazy speed, even to kind of stay in the same place. And then if you want to advance, obviously that becomes even greater of a challenge. So I think one of the things that innovation is associated with in this field is competition. Now, in more specific terms, what innovation is, I mean, I think new ways of looking at data, new ways of applying that data to drive the financial decisions, new ways of optimizing the way our training processes work and the data is exchanged and all of that, the new ways of like innovation in compute is definitely very much relevant for us because all of those firms, including us, are doing a lot of computations, a lot of data, not engineering, data science, and so a lot of model training and all of like any innovation in that field is very much relevant to us. And also, it's like kind of a not you could say it's a dream or a goal, like something that everyone who works at one of those firms dreams of is being able to, innovate something, come up with something that is gonna, just turn the entire thing upside down. Because one of the things that is quite funny about this field is it's very small and in a way fragile. Because if someone starts doing something very successful, everyone else is just immediately forced to adapt, immediately forced to maybe follow the trend or like
Mm-hmm.
whatever happens to be the thing. And so in that field, you're always sitting on a, I don't know, on a bomb, and the bomb can explode at any point in time, and you'll have to reconsider the entire thing, and you'll have to adapt very quickly. So yeah, I think innovation is something that everyone is dreaming of in terms of being able to actually deliver it, and sometimes people do, and it's amazing. In terms of, it's amazing to see how quickly the firm performance can transform and how that affects the entire business. Yeah, I hope that answers.
That was a really, it was a really interesting response, an interesting view you put the word innovation into for us. Lastly, for our listeners who are actually inspired to learn more about your work or just want to follow your insights, where is the best place for them to connect with you?
Yeah, I think the best way has to be LinkedIn. I'm also available to have a YouTube channel that I'm uploading to recently. So I think those two are or reach out by email. I'm reading those emails and I receive a lot, but I still get notification for every single one of them. And so, yeah, I think those are the main ways, the best ways to find me.
All right, Dimitri, I'll be sure to have these linked in the description of the show notes also. So it has been such an insightful conversation with you here today, sir. Thank you very much for joining us on the Iferia TechCast.
Thank you so much for having me. It was huge fun.